Okay, with this lesson, we are going to be factoring quadratic expressions, and this is an important part of Algebra 1, Algebra 2, really, as you get into higher level math classes, but factoring is just a huge thing. You have to know how to do it. The best way to do this, I have learned, is to understand that the coefficient, which is the number in front of the term, the x term, is going to be, it's a 1. And I'm going to grab a marker here real quick. Let's get the right size and colors. And it says a 1. There's a 1 in front of this x squared, and that is the coefficient of this lead term. We call that 1 an a. Any coefficient that's attached to the x squared term is called a. The coefficient attached to the b term is a negative 1 in this case, and then you have c, which is negative 56, which is the constant. It's important to know that this is A, B, and C because sometimes questions come to you out of order. We won't be doing those today, but it's important to know that. Now, at the top of a t-chart, what you should do is multiply A times C together. So in this case, we have 1 times a negative 56, and so at the top of our t-chart, we're going to put negative 56. And that's always A times C. Now, what we're trying to do is find all the combinations that multiply to a negative 56 that could then add to a negative 1. And generally, I start out with, just listing them. And you don't have to list all of them, but for practice, I'm going to go ahead and start systematically. 1 times negative 56 gives me negative 56, but I also have to remember that a negative 1 times a positive 56 would also give me a negative 56. Because 56 is an even number, I know that 2 goes into it evenly. So sometimes it's nice to have a calculator handy so that you can do division with the calculator and not have to try to remember all of your multiplication facts. Just you don't want to make a silly error. So if you do 56 and then divide by 2, you get 28. So it's going to be 2 and negative 28, but that also means you have a negative 2 and a positive 28. Next, you can try to see if 56 divides by 3 evenly, but it doesn't. It gives you 18.6. 56 divided by 4 is 14. So I can do 4 and negative 14, or I can do a negative 4 and a positive 14. Then I can try 5. Obviously, 5 isn't going to go into it because 56 does not end in a 5 or 0. Then you try 6. Does 56 divide by 6? No. Does 56 divide by 7? Yes. You get 7 and negative 8, or you get a negative 7 and a positive 8. Now, some students say, well, how far do I have to go? Well, if the next number would be 8, but you already have 8 listed over here, or a number higher than that, then you're going to stop. You don't need to go any farther because if you put 8, you already have 8 times 7, so you can stop now. What we're going to do next is we're going to try to find a sum, and I'm going to switch colors to make this a little bit more clear so it doesn't get confusing. But we're going to combine this 1 and negative 56, so it would give us a negative 55. And then we have 56 minus 1 is positive 55. And then if we did a negative 28 plus 2, that would give us a negative 26. If we do 28 minus 2, that gives us a positive 26. If we do negative 14 plus 4, that's negative 10. If we do, and that should have been a 14, I apologize. If you do 14 minus 4, that gives you a positive 10. And then if you do 7 minus 8, that gives you negative 1. And then if you do a negative 7 plus 8, that gives you positive 1. What we are trying to do is we're trying to find the combination of numbers that adds to the correct b. So these would be all the b possibilities. Well, the only one that combines to a negative 1 is this combination of numbers right here. So the final step in writing your answer is you take your x's and you split those to be x and x, and then you put a plus 7 and a negative 8, and then that is your final answer. Now that you have the general idea, these will go a little quicker. Again, I'm going to put a 1 in front of this b squared just because I think it's nice to have that there. I'm going to go ahead and make my t-chart so I can show you we're going to do 1 times negative 50. So 1 times negative 50 is going to give us a negative 50. And I'm going to look at my possible combinations that would multiply to a negative 50. So again, I have 1 and negative 50. I have a negative 1 and positive 50. I have 2 and negative 25. I have negative 2 and positive 25. 3 does not go into 50 evenly. 4 does not go into 50 evenly. 5 and negative 10. Negative 5 and positive 10. 6, 7, 8, and 9 do not go into 50, and then 10 I start repeating myself. So what I'm going to do now, I'm going to go ahead and switch back to blue. just because I think it's nice. It keeps everything more organized. If I combine these here, I have a negative 50 plus 1 gives me a negative 49, and then 50 minus 1 is positive 49. Negative 25 plus 2 is negative 23. 25 minus 2 is positive 23. 5 minus 10 is negative 5, and negative 5 plus 10 is positive 5. And if you'll notice that B is a positive 5. So the combination that I'm going to be using is this one right here. So I'm going to take my first term, and I'm going to take the B, the 1B basically, and I'm going to put B here and B here, and then I'm going to do negative 5 and positive 10, and those are my final answers. And just to kind of do a quick check to make sure you did it right, if you multiply B times B, you get B squared. And if you multiply negative 5 times 10, you do get negative 50. And then if you added negative 5 and 10, you get positive 5. So you can always do a quick little check at the end to make sure that you did that correctly. So then we're going to skip down to this question here. Again, I'm going to have two positives this time. So I'm going to multiply 1 times 30 and get 30. Now, when everything in the entire question is positive, then you don't have to worry about listing any of the negative possibilities that would multiply to a positive 30. It's just when you have one of each, it gets a little bit confusing, or when they're all negative. So we're just going to do the positives because everything's positive. So 1 and 30, 2 and 15, 3 and 10, 4 does not go, 5 and 6. I believe that's it because you start going up the other direction. We're looking for the combination that adds to 11. So if I were to add here, I get 31. Here I get 17. Here I get 13. Here I do get 11. So this is my combination that adds to 11, which is what I want. And so I'm just going to make my two sets of parentheses. I put a K here and I put a K there. And then I have plus 5 and plus 6. And that is my final answer. It goes a lot quicker once you understand what you're doing. Now, in number 4, I think this is a good one to go over because notice that our end term is positive, but our middle term is negative. So in order to have two numbers that multiply to a positive but add to a negative, both of those numbers would have to be negative. So I'm still going to start this the same way. I'm going to do 1 times 70, which puts 70 up there. And then I'm going to start listing my possible combinations. So I know that 1 and 70 multiplies to 70, but that adds to a positive 71. That would mean that negative 1 and negative 70 multiplies to a positive 70, but it adds to a negative 71. So notice that the middle term has to add to a negative number. So really that means we just need to worry about the two negative combinations that multiply to a positive 70. So we have negative 2, negative 35. 3 does not go into 70 evenly. If you do 70 divided by 4, it doesn't go. 70 divided by 5 does go. And so if you do 70 divided by 5, you get 14. And so you're going to do 5, a negative 5, and a negative 14. Then we try 70 divided by 6, and that doesn't work. 70 divided by 7 obviously goes 10 times. So we have a negative 7 and a negative 10, and that actually is going to be my combination. Negative 7 and negative 10 combines to a negative 17. So I have two terms. I've got K here, and I've got a K here, and then I'm going to go ahead and write my minus 7 and my minus 10, because when I multiply negative 7 times negative 10, I get positive 70, but when I add negative 7 and negative 10, I get a negative 17. Okay, so on to the next one. We have a situation here where we have a negative 30, and it's 1 times negative 30. So we have negative 30 at the top. And if we just start with our combinations, we have 1 times negative 30, and we have negative 1 times positive 30. And again, once you get used to this, you kind of figure out what you can and can't do in terms of or which ones you should and shouldn't include. Because our middle term is a positive number, we're going to want to keep our positive sums. So obviously, if I were to take 1 and negative 30, that would give me a negative 29. And if I do negative 1 and positive 30, then I would get a positive 29. So we're going to try to do the negatives on the left and the positives on the right. So if I do negative 2 and positive 15, that would combine to a 13. And then if I do negative 3 and positive 10, that would combine to a 7. And then if I do negative 4, it doesn't work, and then negative 5 and positive 6, that would combine to a 1. So I have now found my combination that adds to a positive 1, which is my B term. And so again, I'm going to take my two parentheses, and I'm going to split them. I'm going to put X here, and x here, and then I'm going to put my -5 and my +6, and that is my answer. One more here. I've got p squared minus 17p plus 72. Again, I'm going to put a +72 up here, and I'm going to do 1 and 72, and I have -1 and -72. And so in a sense, I can just focus on my two negatives because I need it to multiply to a positive but add to a negative. So that would be -73, and then I have a -2 and -36, and I have -3. So 72 divided by 3 is 24, and so then -3 and -24, 4. 72 divided by 4 does 18, so I have -4 and -18. 5 doesn't go. 72 divided by 6 is 12, so I have -6 and -12. Let's see, 7 doesn't go, 8 and 9. So I have a -8 and a -9. And there's my combination, because -8 and -9 adds to a -17. So then I have my p that I put here and here, and then I have -8 and -9, and that is my final answer. Now the next part of this video, it's kind of the same thing, except for that now we have a lead coefficient that's greater than 1. And there's different ways of approaching this, but in this case, I'm going to go ahead and divide out that 4 into every term. And the reason I want to divide it out is because I'm trying to get rid of that. It's called a GCF, greatest common factor, and it's actually part of the answer. So when you divide that 4 out, you get x squared plus 3x, and then 72 divided by 4 is 18, so then you get -18. We want to keep this 4 here because it's part of the answer in that we had to undistribute it. Think about when you distribute, you do 4 times x would give you 4x squared, 4 times 3 gives you 12x, 4 times -18 gives you -72. Well, when you factor something out, you're you're reversing it. You're undoing that multiplication, that distribution. So that 4 is going to be part of the final answer. That's important. But the rest of it now is just like all the other questions that we just did. You take your 1 times -18, and that goes here, and you try to find the combination that multiplies to a -18 that adds to a 3. So you have -1 and 18, or you have 1 and -18. And you just kind of do your combination. I believe it's going to be a 3, a -3, and a +6. And you do get to the point where you get quicker at this when you've done this enough. And so now I'm going to go ahead and take my two sets of parentheses. I'm going to split my x's here and here because x times x is x squared. I'm going to do my -3 and my +6. And you'll notice it doesn't matter if you put x plus 6 first and then x minus 3. It doesn't matter which one you choose first. It's just as very important that on these last 6 questions you don't forget to include that greatest common factor of 4. I'm going to pause the video here and have you guys work it out, and then I'll let you see the solution. So hopefully you had a chance to work this one out. If you take the 4 out by dividing it out, you get 4 in front, and then you have x squared plus 2x minus 24. And you're trying to find two numbers now that multiply to a -24 that add to 2. So those two numbers would be -4 and 6. And then your answer would be 4. Don't forget that 4. It's part of the answer. You have x minus 4 and x plus 6 as your final answers for that one. Go ahead and pause the video again. Try the next one. Okay, so hopefully you were able to do that problem, and you see that you have x squared plus 7x minus 18 once you divide that 6 out. Again, that's your GCF and part of your final answer. Don't forget about that. And then you take your two numbers that multiply to -18 and add to 7, which would be -2 and 9, and place them here and there. Go ahead and pause the video again and see if you can't do the next one. Okay. So on this one, we divided our 3 out, which is our GCF. Again, remember that's part of the final answer. We have k minus 4 and k minus 6 because -4 times -6 gives us a +24, and -6 and added to a -4 gives us a -10. Go ahead and pause the video again and do the last two. Okay, let's see how you did on the last two questions. We've got 11 and 12. So we have 6 that we took out of each of the terms from 11. We factored that out and placed it in front, and then we placed it also in our final answer. We found two numbers that multiplied to a -50 and added to -5, which were 5 and -10. And so my final answer is going to be 6 times n plus 5 and then m minus 10. And then over here, we have 5 that we took out as our GCF, and again included that 5 as in our final answer. Two numbers that multiplied to a negative 27 and added to a positive 6 were negative 3 and positive 9, and that gives us our final answer. So I hope that this has helped you understand how to do factoring when you have a lead coefficient of 1. We will be doing some more factoring in another video shortly.